Chapter 10.2, Probability. So yesterday in Chapter 10.1, you found sample spaces. You were given some items and asked to find what is the sample space? What are all of the different combinations of outcomes? For example, if you were given an ice cream flavor with a topping and some cones, what are all of the different combinations you can create? Today, we're going to talk about the probability of one of those combinations actually occurring. So our vocabulary for today is equally likely outcomes. For example, a coin toss. If I toss a coin, the chances my two outcomes are equally likely to happen. I have heads or I have tails. They're my only two choices, and they're equally likely to occur. Looking in this diagram up here, I see that I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. Okay? Only 2 of them are green. So the chances of getting a green are 2 out of the 10. But if I look at the yellow, it's 4 out of 10. Oh, I'm sorry, 5. 1, 2, 3, 4, 5 out of 10. So these are not equally likely outcomes. The chance of me getting yellow is much higher than me getting green, simply because there is more yellow than green. We call this the probability of an event. Okay? It describes how likely that event is to occur. So we also have complement of event, and we're going to talk about that after example 1. But go ahead and take a quick look at that vocabulary right now and get that written down. So how do you find the probability of the event? So the probability of an event is the number of favorable outcomes, the number of times it actually happens, over the total number of outcomes possible. It is written as a fraction. So if we go back to our spinner, the chance that I spin a green is 2 out of 10. There are 2 chances I'm going to get a green out of a total of 10 possible spaces. Now I could also reduce this to 1/5, 1 out of 5. The chances that I'm going to get a blue or a yellow, switch colors here, the chances I'm going to get a yellow are 1, 2, 3, 4, 5 out of 10, which reduces to 1/2. And the chances that I'm going to get a blue are 1, 2, 3. 3 out of 10. So probability is just a fraction relating the chances of a certain event happening, getting a certain color, out of the total number of possible options. So let's take a look at example 1. You roll a number cube one time. You roll a number cube once. Find P. Notice this capital B. P stands for probability. I can spell. Let's try that again. Probability. That's capital P stands for probability. And then the event that I want is going to be in parentheses after it. So find the probability of rolling an even number. Well, on my standard number cube, my even numbers are 2, 4, and 6, which means there are 3 even numbers that I could roll. There are a total of 6 numbers, though. So the number of evens over the total number of options. So I could roll a 1, I could roll a 2, I could roll a 3, could roll a 4, could roll a 5, or roll a 6. there are 3 different even numbers. So any of those 3 will satisfy rolling an even number. So the probability is 3/6, which reduces to 1/2. Just like with fractions, with probability you always want to reduce. Okay? Make sure you reduce your fractions whenever possible. Okay, let's take a look at example 2, and now let's talk about the complement of an event. Actually, I'm going to come back here to example 1 really fast. So the complement of an event is all the collections that didn't happen. So in example 1, if the probability of finding an even number is 3/6, its complement would be the probability of rolling any other number, or in this case, rolling the odd numbers. So the complement would be 3/6 or 1/2 also. These represent the odd numbers, okay? The complement is anything that didn't occur in your first set of your first probability, what it was asking. So, example 2. Of 20 students in a class, 18 of them are 12 years old. The teacher selects a student at random. What is the probability that they select a 12-year-old? And what is the probability of selecting someone not 12 years old? So, this is the probability. This is the complement. So first I'm going to find the probability of selecting a 12-year-old. And it says there are 18 12-year-olds out of 20 altogether, which will reduce to 9/10. So the probability of the teacher selecting a 12-year-old is 9/10. Now, if 18 of those students are 12, then 2 of those students are not 12. So the probability of picking someone who is not 12 years old is those remaining 2 students out of the total, or 1/10, or 1 in 10. Okay? All right, example 3. Probability can range yeah, we'll cover this now. Okay. Probability can range. If I was to think of a really bad number line here, I can have 0 probability that something is going to happen. If I flip a coin, what is the probability that I flip a 3? The probability is 0. It is impossible. It is absolutely not going to happen because a coin does not have a 3. Okay? Everything to 1. What is the probability that the sun will come up in the morning? It is absolutely certain, barring any major catastrophic events, which we will not take into consideration. Okay? But if the Earth keeps turning the way that it has for the past who knows how many millions of years, it is certain that the sun will come up in the morning. So its probability is 1. It is absolutely going to happen. Other probabilities fall somewhere in the middle. Okay? If it falls here at the half mark, it is equally likely or unlikely. Flipping a coin goes here. What are the chances I'm going to get heads or tails? It's 50-50. It's equally likely or equally unlikely. So this end over here is considered to be less likely. The closer you get to 0, the less likely you are going to be. This 1/10 is less likely. You are much less likely to pull someone who is not 12 years old than you are to pull someone who is 12 years old. Okay? That, the closer you get to 1, the more likely you are that something is going to happen. You are much more likely to draw the name of someone who is 12 than you are to draw someone who is not 12. Okay? So let's take a look at example 3. You are one of 100 students who work for a fundraiser and are eligible for a prize. There are 11 prizes. Names are drawn at random. What is the probability that you will win? Write your answer as a decimal. So, the probability that you will win a prize is the number of prizes available out of the total number of people who want that prize, okay, or who are eligible for that prize. So now that I have it written as a fraction, now we'll convert it to a decimal. Your chances of winning are 0.11, or also known as 11%. 0.11, fairly close to 0, so it is not very likely that you will win a prize. It is not impossible. There is definitely a chance. It's just not a very large chance at only 11/100ths or 11%. There are a whole lot of people competing for not very many prizes. Okay, that's it for examples. Go ahead and complete your QCs and your CYUs. And if you have any questions, I will be glad to answer them the next time I see you.